Hey everybody, I hope you all had a great day, or are having a great day so far. Mine's not been too bad. Right now we actually have a plumber here at the house, so I might have to uh, pause the stream for a bit to go check on that, but I think somebody else is taking care of it, so it should be fine. But I do have both my pets in here with me so they don't bother him, so you might get a glimpse of them. Let's get to some programming. Hope you all are doing well. Oh, 1 second. All right. Okay, I'm back now. So, let's see. There's one thing I wanted to do. Actually, like yesterday, I had this test rotation direction function, and I was not very confident in it, but it actually worked pretty well. This is basically just a cross product, and we already use a 3D cross product to tell if it's going to be clockwise or counterclockwise, so I should have expected the same thing, but the only thing I had to change is Unity, whenever there's a rotation of exactly 180 degrees, it actually will rotate it clockwise, but without this check, the function would return counterclockwise, so I just had to add this little kind of hacky thing, but so that's pretty much that. Alright, so one other thing I wanted to add. Let's go ahead and just show the animation so far. But basically, whenever he jumps and hits the ground, I'd like to have a special animation for that. Kind of, we already have like a wind up animation for jump, so I guess it'd be a wind down. Oh yeah, the camera is too far away. All right, so right now he just jumps. It actually doesn't really look that bad, but I think it would look a little better if the only thing is that if it has to rotate, we'd have to wait for that animation to end. I guess that's not a huge deal, but seems like the tail is still clipping a little bit. All right, well anyway, let's take a look. Oh, you know what? I probably didn't rebuild the asset bundle since I changed the idle tail anchor. So maybe that's the reason why it was still clipping into the eggshells on those dinos, but on this one it should be better. Yeah, I mean, it's still almost hitting it, but... Alright, I need to press record first. Oops. Maybe instead of that I should move it. That might do the trick. Probably also should move upwards a bit because I think the shell does. Is something weird going on? Yeah, it's like snapping. Oh, maybe it's because this. Oh, yeah. I need to copy and paste the position and rotation to there. That should do the trick. That does look better, but I'm gonna try something weird. Let's just move it like really far upwards. And I wonder if it's getting overwritten. I really hope not, but okay, no, it's not. It's just not totally obvious. Oh, why'd it move? Oh, okay. I see what's going on now. So now if I just copy that back, everything should be back to normal. Yeah, it's fine. I think I'm just being nitpicky. All right, so let's see. How would I do it a landing animation? I guess right here. The only problem is if we did landing, we'd need to wait for that to be over to do a rotation at the end. I guess that's not a huge deal. Okay, they're all lowercase, so I'll keep it like that. I don't need a semicolon. And then here, if we have a landing animation, let's just actions wait for a specific timer. I forget the function call for that. Okay, start timer. We could also wait until this animation gives us a signal, but I think start timer would be safer. Okay, let's just do like a quarter of a second. Okay, and then in the animator, we'll just add a trigger here. Okay, I don't know why I didn't capture my key presses, but whatever. Okay, and we'll come back to add the state. Oh, okay. Yeah, this is a little confusing. I have this landing animation, which is when he's still in the air. Okay, so let's call this round our land. I forget the technical term, but basically not anticipation, that's before. I don't know. I guess rebound. I don't know if that's the best term, but we'll go with it. Okay, so really, he's just gonna kind of have a single frame and then it will ease in and out of the other animations into this. I'm thinking it'll be kind of like he's squished down, of course. Should this be rotated, I wonder? Maybe downward a bit, I don't know. Okay, and then we obviously need to fix the tail. That's another thing also, like the tail animation. The tail probably should be animated a bit more. Because right now, especially when he jumps, it just keeps wagging, and I mean, it looks okay, but I think I would like to revisit that. Okay, and what about the legs? Maybe move them just a bit apart. I'm just trying to eyeball it to see if they're roughly equal. Okay, and then maybe I'll rotate the jaw upward just slightly to look like he's kind of clenching it. I don't even know if that's very visible, but... Oh, I didn't record any of this. I don't think there's any way I can bake these changes into it. Oh, that's a shame. I keep on doing that. I really need to... I don't really know how Unity could prevent that from happening, but I just need to remember. Okay, so yeah, we moved that a bit. And then the head down and inward and rotated slightly. And then I move the feet apart. That clips to the outside actually, so I don't want to do it that far. Okay, and then the tail. Alright, so that's good enough. And really, we don't have to do anything else except I need to add another frame. I don't know, right here. So that way the animation will at least play this long until it blends. Okay, let's see how that looks. I mean, I could do a little bit more fancier, like maybe the shell even moves farther down or something, but... Or it shakes a bit. Okay, so now back into the animator. Oh, I guess I should turn recording off. Okay, now that's correct. This land rebound is a new one. Okay, do I want to just, I mean, it needs to blend right from landing actually. So maybe I won't even have it exit. So this would happen on the trigger land and no exit time. Well, yeah, it should transition a lot quicker than that. Okay, and then here it will start to transition. I guess maybe. Okay, it does have that. Okay, so that means it's going to start blending immediately when it exits. That might be a little too fast. We'll have to see how that looks. So actually, there's no way to exit any of these unless you do this whole chain. Which I think will be fine. So really, there's no reason for this jump to be false, but... Okay, let's change this, because we're actually using it not just for sound effect. Okay, so let's try this out. Well, first, we'll do it in the normal play mode with this before I export the asset bundles in case there's some bug with the animator. So first the sequence would turn jump on, and then at some point it hits the apex and turns jump off. And then after that it'd go to landing. That's pretty good. Okay, yeah, that's fine for now. Might come, I don't know. It's a little awkward. We might come back and fix it later, but we need to do the tail as well, so I mean, we can spend forever on animations. Okay, so let's do better tail animations. But I kind of want to move on to something else. Alright, so it's still thinking. It won't let me exit back into Unity. Guess I could get the folders ready while I'm waiting. Okay, so we need the asset bundles and the streaming assets, which is where the mod folders are. Okay, and we can just move this over here. Okay, and now the spawned egg dinos, which are from the asset bundles, should be using this new animator. So let's look and see how the jump looks now. Okay, there's a bug. Parameter name for an animator must be non-empty at line 70. So what did I do? Oh, I didn't pass the user. It's an issue. I was actually thinking like, so I have like a separate audio source object for an audio source, and I was wondering if I should do something similar for an animator. So that way we don't have to always pass the user to set a trigger. I think that might be a good idea, but I don't know if I'll get to it right now. Let's have a little note here, I guess. Create animator or model class to make set bool, etc. easier to use. So basically we just move all set boolean, set trigger, and probably the movements and everything to that animator class. And then in animations we just have get animator. But yeah, we won't do that right now, just because I do want to move on to shaders. At some point when we do some more code cleanup, we can get to that. I probably will want to do it, obviously, before I write some more ability scripts, because otherwise we'd have to change a bunch of stuff, but... Alright, it's not too bad. I mean, it gets the job done. I think it could definitely use some more work, but... I mean, the animation itself, the code is fine. It's a little awkward, I think. I don't know, it seems to transition a little too fast. Oh, how come we can't go up here? That's a bug, but... Anyway. I think that's good enough. Okay, so yeah, we'll put better tail animations on hold for now, and same with the colors, because I mean there's no reason to try and edit the colors without a completed shader, so let's move on to the shader. And I've been reading a lot about shaders lately. I'll put this, and I've learned quite a bit about them. Let's look at the one we used so far. Okay, so I just have the terrain shader. So actually, the egg dino, does it just use a standard shader? Trying to find the egg dino material. Oh, it uses the Toon Lits shader that comes with Unity. So this one's not bad. And yeah, it uses a surface shader, which is kind of like a shader generator. Actually, let's update my stream title. So I guess I'll just making a Toon shader. Okay, let's do a slightly snappier title. There we go. So surface shaders are actually very nice because they basically give you most of the what's the word, features of the Unity standard shader. So you get the physically based rendering, as well as let me just open up or create a new material with the default shader. And you get basically all these, you can implement all these things And albedo is just the flat color of a object, and then you can set metallic, which basically controls the balance between the shininess of a color, of an object and its albedo. That's what smoothness does as well. Where does it have the specular color? Specular is a shader term for shiny lighting, I should say. And then the normal and height maps are ways that you can trick the eye into thinking that there's bumps and texture on a surface. We actually won't need that for this game because since it's low poly, we kind of want everything to look flat. So that's another reason why I don't know if we'll use the standard shader. And then there's some more stuff, like you can have detail textures, which are actually really cool. And they're like a separate tileable texture that you can set to display on an object when you zoom in close to it. And some other things, but the issue is kind of like what I was talking about yesterday, that I wanted to support the deferred lighting or deferred rendering pipeline. If you have a unique lighting function for a surface shader, you can't use a deferred, because how the deferred pipeline works is that basically lighting becomes a full screen effect. So the shader actually stores textures with all the colors and all information about the geometry, and then another separate shader comes and applies lights to them. And the big benefit to that is that you only have to do one draw call per light instead of one draw call per object per light. And I kind of think this game might have quite a bit of lights because I kind of want some of the monsters to have shining eyes and things. So also deferred is just kind of the newer and more efficient rendering style, so I definitely want to support it. Yeah, so that's one reason why I don't think I'll use the surface shader, but another reason is just because I kind of want to learn how to write shaders myself, and I think that's pretty much the whole point of this game project, is to be able to try things I normally wouldn't. So I think, yeah, so I'm going to try to write a Toon shader from scratch. But, well, I guess not completely from scratch, because I'm going to be using a really good tutorial as a base. I think I've used this or talked about this before, but this fun website called Cat-like Coding, I'd really recommend if you're interested in rendering. They have a huge tutorial list on how to write your own, basically replicate the Unity standard shader. And then they also had a bunch of stuff on hex maps, which helped me, especially with shading the terrain. So I definitely recommend it. Again, it's catlikecoding.com. And probably need to refer to this every once in a while because shaders can get really complicated very fast. I also have Unity's, didn't mean to click on that, Unity's default shaders that we'll probably be referring to, because it's easier to actually use the default shaders than to try and read the documentation. So got folders, so many windows open right here. So the cat-like shaders and then built-in shaders. So we'll be referring to these. Okay, so we have the terrain shader, and we'll leave it for now. I think this is yeah, a surface shader, and it works fine. But again, actually this doesn't have a unique lighting function, so I think this program would actually, or this shader would actually work with deferred. Let's check it out. One way you can see is if you go into the show generated code. Oh, don't do that. And see if it has a deferred pass. Okay, and yeah, this is code that Unity generates from the surface shader. It's a bit hard to read because it doesn't have good intention. Okay, so let's forward add. I guess I kind of just want to see all the light mode. Okay, it does have a deferred pass. I thought so because there's no custom lighting. Okay, but I'm gonna kind of write the shader starting simple and moving upwards because like I said, there's all different features of the Unity standard surface shader, and I'm not planning to completely replicate everything. I basically just want a Toon shader that fits to exactly what this project needs. Okay, so first let's add Toon. Okay, well actually I should add it through Unity to start with. And we'll actually have an unlit because I'm going to be writing everything itself. So I'll just call this, I guess Toon is fine. Okay, it's thinking. So now we have it open here, and I want to rename this to Tactical Lizard Tamer Toon. I think I did the same with a terrain shader. Yeah. And we can see it kind of just has a really basic shader here. I'll kind of walk through it, although again, if you want a tutorial on shaders, I'd really recommend Catlight coding. So here is just some properties about the shader. When we apply it, let's just make a Toon here, Toon material. Probably, yeah, let's make some test objects. So we have a sphere. Let's do a cube and a capsule, I guess. Let's put them in one test object so I don't have to enable and disable them individually. And I'll give them the Toon. So right now it's just actually, oh, because it's a surface shader, it still has lighting. Or no, it's not a surface shader. Oh, I didn't set this. Yeah, so they're just going to be plain white because there's no lighting. Let's move them apart a bit. So yeah, no shading. First I think I'll should get some kind of texture to test this. Do I already have a testing texture? I think I have a checkerboard that I'll just use. Okay, I have the dirt checkerboard. Well, that's fine because it has some color, so I think the stone would actually look better though. Oh, but we don't even, oh, we do have a texture, so. Okay, so now it at least has a texture. All right. So basically what this does, these structures are kind of the information. Well, I guess I'm getting a little ahead of myself. A shader has kind of two separate programs that make it up. there's the Vertex program, which is usually just one function, and it takes input about every vertex in a mesh, and then it outputs information about the vertex in the camera's view, as well as any UVs for the texture that we want to apply. And then the fragment function runs for every pixel that the renderer detects is inside one of the triangles of our mesh. And it needs to output the actual color of that pixel. And the input, this v2f, is the input, or the output of the vertex function is input to the fragment function. These are called semantics, and it basically tells the rendering engine what data to insert into this variable. So position, and text chord 0 is the UV. And then here is information about this texture that the material supplies, and then these are the actual vertex and fragment functions. I guess I'll walk through this a little bit. So Unity object to clip position transforms the Unity's local vertex position, which again, if you're used to Unity, you know that there's local space and then world space. And every vertex in the mesh is in the object's local space, so we need to transform it. And it's done with matrices and stuff, but Unity has this specific, or this helpful function that will do it for you. So again, it transfers from the object's local space to the camera's view space. And then this function transforms the UV and makes it appropriate for this texture. It uses this main texture. I think it's called scale transform is what the ST stands for. And if you look at the material, you can set this and basically change how often something tiles. Maybe we'll make it tile a little less. And so that this information is stored in the this main texture ST variable, and that transform text uses that. And then I actually don't want fog, so I think I'll get rid of the fog. Yeah, no fog for now. Let's keep things really simple. Okay, so one thing I'm going to do is, right now we only have one pass. And a pass, basically a shader can be called multiple times. Like for deferred, it's only called once to get the main information about the color. And then in forward shading, it's called once for the base light, and then once again for every other light. And they could be slightly different, so that's why they let you supply different pass variables or pass blocks. And since we're going to do that, we're going to have pretty much a similar function in every pass. So it'd be nice if we could write these functions in another file. And you can do that with something called a CG include. And if you've ever used C# and used their include, or not C#, C++ and used their include files, it's pretty much the same thing. Okay, well, we'll just use class, but we're going to change it all. So this will be Toon lighting dot CG INC, which stands for CG include. And yeah, we won't want any of that. All right, so I'm going to open up my lighting from Catlight Coding, and we'll kind of use it as a base. One difficult thing about CG includes that you have to remember is that the compiler is not really smart, and if you include CG include twice, it will duplicate everything you write in here. So you have to have this preprocessor directive, which tells it to define this variable. And then if it's already defined, then we won't execute anything inside this block. So we should change this to Toon lighting. Actually, let's do that. And then what I want to do is take everything out of the Toon shader and put it into that. I think. Okay, we don't even have to do the NCG and stuff like that. It's mostly just this code. Okay, and now I think if I go in the Toon shader, I can delete this and just include the Toon CG include, and it should work. And this knows to look for some function named that, which we have supplied in the Toon lighting. So okay, and it still works. So good. Okay, so now we can get to the fun part. Okay. Again, the fun part. Need to figure out how to start. So yeah, we do want the position. And I'm going to kind of use functions like this to just help with everything. So yeah, we'll do and get Albedo. Which again is just a color if you had no specular lighting or no shiny lighting. I want the UV and the vertex, so this is fine. I don't know why it's flipped there. Also, I think I prefer the code style where the curly braces start on the same line as the function declaration. Okay, so we can leave this. And all I really want to do is have a function get albedo right here. And how does this work? It's really simple. We just need to okay. So we sample the texture and then Unity instance. Okay, this is for GPU instancing, which I'm not going to worry about right now. That's a pretty advanced topic to try and save a lot of draw calls. It's definitely worth it, but that's something we would do later in a optimization pass. So really all we have to do is just read the texture and then we just return that. And I'm not going to support transparency in this shader, so that's another thing we won't have to worry about. So float 3, get albedo, and we'll have v2f input. And again, we'll just return this really. I don't think I want to add anything else at this point. Okay, there's something wrong. No matching, 0 parameter. Okay, I think some parentheses somewhere is not. Oh, yeah. That should be get albedo I. Implicitly convert from float 3 to half 4. Oh, you know what? I need to... First of all, I'm not sure why this is fixed for. Why does Unity want to output that? Because I would have thought it would be a float. Let me see, how does Catlight coding do it? Okay, they do have a special fragment output because they use are getting ready for deferred, which we're not going to deal with right this second. Okay, so it is just a float 4. I don't know. Yeah, it seems like that would have better colors because it's a full byte for each. But then I do need to supply the alpha, and to do that, I'll just use this helper function. And so it takes the red, green, and blue value from get albedo, which actually I should do that. And then adds 1 to the alpha. Or not adds 1, sets the alpha to 1. If you're not used to shaders, they have this cool thing called a swizzle. And basically, if you have a vector, you can type the components of the vector in whatever order, and it will return that for you. So this would return a float 3 vector with the blue, red, and green in that order. And you can do that with colors or X, Y, Z. It's really, really nice. Okay, so let's see. Okay, now we've got back to our brown checkerboard. Okay, so do I want to do... I guess lighting would be next. And let's just do flat lighting, so no specular at this moment. And I'll probably only handle directional light for now. So I'm going to try and follow the format here. Okay, so it kind of does the lighting right here. So yeah, this is for specular, so we won't need that, but we will need to get the view direction. Which we'll need to get the world position for this object, which we don't have at this moment. Let's not worry about the view direction right now, actually. That's interesting. So, okay, yeah, so this is where it creates the light. I knew that it did the light somewhere. Okay, and this is the function, this Unity BRDF PBS. I'm not sure exactly. I think it's physically based rendering. Well, it is a physically based rendering function. And you give it all this information, and it makes a really nice lighting, or I guess shading effect. But unfortunately, we can't use it because it doesn't use the Toon lighting. I think this is pretty much the reason why I'm going to look in the built-in shaders, because we'll probably just copy the code out of this and add in Toon lighting. But right now, I just kind of want to have just plain lighting, just so we can get that working. And in order to do that, I want to find the create light function. And if you're wondering, indirect lighting is like ambient lighting and reflections, which we will get to at some point, but... All right. So I'll copy this function over for now. Okay, and yeah, we don't use interpolators. I'm just going to use Unity's standard variable function names. Okay, yeah, so this, during the deferred pass, the lighting would not be calculated right now, so it just returns dummy values, but we're not going to have a deferred pass right now. Speaking about that, okay, we just have one pass. I should add a tag here, I think. I forget what the correct tag to put in there. Okay, yeah, light mode. So yeah, I wanted this to be forward base. I should also do blending. I forgot about that. Okay, so it's going to complain because it doesn't know what a Unity light is, and we'll get to that. Okay, so this is the base pass of the forward shader, where it just takes care of the main directional light. And we'll just do normal blending. It's actually source alpha, and then 1 minus source alpha. We touched on this a bit when I was doing our 2D mask shader. And this really just tells the shader, or not the shader, but the graphics engine how to blend the output of our object with anything that's behind it. And this just means we take the alpha and then 1 minus source alpha for the other object. But actually, this is going to be opaque, so I think we can just do 1, 1. Because we're not going to have transparency. And then z-test. What is the... I guess we don't really have to do that. We can just use the defaults. This really just tells it how to deal with depth testing. So I'll just leave the default for that, because that's pretty much how we're going to want it to work. Alright, so if we look in here, or wait, our Toon lighting, we'll need to, I think, include Unity's auto light. CG include file. And that's where this Unity light is defined. If I do that, oh, it still complains. It must not be auto light. Or is it fixed now? Well, it's still pink, obviously. Okay, yeah, there's a kind of annoying bug with shaders where sometimes you can't tell if an error is current or not. It seems like there's obviously something still wrong with it because it's pink. But it might just be because this is not taken care of yet. Okay, so I'm not going to use a lot of this information right now, because this is for different types of lights and also shadows, and we can add this back later. So really we just need to have the direction, which is the world space light position, and then the color, the light's color. And again, I'm going to assume that I'm in the deferred pass, and also that it's a directional light. Okay, so no shadows. A very simple light. Hopefully, okay, it doesn't, yeah, so it doesn't know what Unity Light is. What is the file that includes that? It must be physically based lighting. So we will use that, so I'll go ahead and include it. Probably don't need to include that now, actually, because I think it's already included in one of these. The undeclared identifier attenuation. Let's see. Oh, right. That's for shadows. Okay, so now it's really bright. It's also... Oh, because... Actually, I don't know why it's doing that. Maybe it's the blend mode. Okay, so I'll just leave this out for now. I'll just have it on the default. I'm surprised. Yeah, it must have been the blend mode. Oh, because I was doing additive blending. Okay, so it should have been, yeah, 1, 0, but this is fine. Okay. So now let's actually add some lighting. And the basic of it is, or the basics is, we take the dot product of the lighting direction with the normal of this face. And we multiply that with the color to get the actual lighting for the light. And that's like the simplest lighting possible. Okay, this is fine. So float. Oh, I guess we gotta get the Unity light first. Create. Oops, it needs an equals. Create light. Okay, and float dot is dot. Okay, so we need the normal, and we don't actually have that yet. And we'll pack that in here. We need the normal in world space. Okay, and even though we're saying that this is like a second set of UVs, you can actually just put whatever you want into these values. So we'll use it to store the normal. All right. So now we need to transform the normal, and just so that I can get the math right. Okay, so that's fine. Float 3 normal, and then yeah, it puts it in here as text chord 1, just like I am. Where's the vertex function though? Okay, here. Okay, Unity object to world normal. I thought that's something like that. I thought it was something like that, I should say. Okay, so this should be O normal equals V normal. And the reason we have to do this is, again, we need to transform the normal from local space for this object to world space, and that's what this does. So now that we have the normal, we can take the dot product, and I think it's... Yeah, we have to take the negative light direction because they need to point in the same way, and the light is actually pointing towards, or in the direction it's moving, and the normal is pointing outwards, so it'd be negative light direction dot I normal. And how about, just to visualize this, let's just output the dot product on our objects. Okay, that's not gonna work. Not a function. Oh. Yeah, I can't do this. Yeah, I was using a keyword. Okay, so now we can see where the areas where there will be more light. Interestingly, is that the way that the light is shining? Okay, so this area should be light, so I think I got it backwards. Maybe I don't negate it. Maybe Unity's already taken care of that for me. Yeah, I guess it did. And one other thing that we can notice is if we take the dot product, multiply it by 2, and... oh wait. No, we want to divide it by 2 and add 1/2 so that it's normalized, because dot product, well, usually between 0 and 1, or -1 and 1. And if we see that it actually has like negative values where the light partially shines, and would subtract color away, and we don't want that to happen, so we need to clamp this, which we can use a function called saturate, which basically clamps this value between 0 and 1. Or not basically, that's exactly what it does. Okay, so now we won't have any negative values, not that you can actually tell, but... okay, so now let's apply this to the color, and so you can just multiply the light dot to the color. Oh. Add an extra R where it's not needed. And so this is like the simplest lighting that could be. And if we want to add Toon lighting, you know what? I should also have an egg dino here to see how that looks. Let's just copy that part of it. And move this over. And let's rotate it so it's facing towards us. And then I'll just change the material to use our Toon shader. Well, I guess we wanted to use the actual egg dinos material. I'll duplicate this. So I wanted to use the same shader, but I wanted to use the egg dino's texture. Is what I was trying to do. Okay, that's kind of weird. Why is it green like that? Oh, because of tiling. Okay. So now it doesn't have any ambient light, so it's kind of messed up right now. But yeah, basically we're on our way. And now let's try to Toon shade it. So for Toon shading, the main idea is that instead of just multiplying this light dot, you use light dot to sample a ramp texture. So we'll add another property here. 2D is white. And then sampler 2D Toon ramp. Okay, and let's see. So float Toon multiplier is texture 2D. Oop. Toon ramp. And then new vector 2. Or wait, I'm using the C# syntax. So yeah, we just use the light dot to sample the texture. And then we multiply that by the color. So right now it doesn't do anything because, wait. Oh, I think that D needs to be capitalized. Okay, so right now the ramp is completely white, so that's why lighting has disappeared. So we need to get our Toon ramp. I already have one, but it's not really that great. Let's just make a new one. I could just use this. Document properties. One important thing about shaders is it's better for everything to be a multiple of 2 or a power of 2. We'll do something like this. Okay, I don't want any stroke. And I'll just do something very simple for now. Doesn't really need to fit exactly, but okay, let's put the document on top of the... Oh, that's not what I wanted. Edit. Oh, document properties is in file. And so I want the border on top of drawing so we can actually see what's going on. Okay, and now let's export this. Let's put it in the base folder because that's where I'm working right now. Toon ramp. Alright, and so the Toon ramp, we want it to not be an sRGB because it's a data texture, not specifically color. And we don't need maps. Oh yeah, so it's just default. Okay, and filter, definitely point, wrap, repeat. Oh no, it should be clamp actually. Okay, this should be fine, I think. And now I can assign the Toon ramp to both of these objects. Okay, and now it's already updated, and it has just a very hard cutoff because we only have one color. This is pretty much how it's supposed to look. Although probably not quite so hard. I guess it depends on how we want to deal with it, but so basically now we have a very basic Toon shader. Yeah, that was a little... So what do I want to do next? I could add more lights. Maybe I should get deferred rendering working. Yeah, let's try and do deferred because I know I want to support deferred rendering. So to do that, we have another pass. And then deferred. Okay, and I forget if Unity will automatically define certain variables for you or if you have to do it yourself. So let's look and see how it's done here. Okay, yeah, so they are cat-like coding defines variables for different passes. So we will do that too. And so our functions can use this to slightly change their logic depending on what pass they're called in. Oh, does it? And we won't worry about this forward add. That's for in forward rendering for additional lights. I probably will support that because we need to support forward rendering for less, I guess, up-to-date computers. Also, phones can't use deferred pass, even though this game's not going to be on a phone, but just for your information. Okay, so what we'll have to do is during a deferred pass, so if, I think it's actually lowercase, but if defined deferred pass else actually I forget the syntax. So yeah, I know it's end if, but is it, so it's just else, but is there an else if? Okay, yeah, it's elif. Yeah, all different kinds of languages. They can never, like, there's no standard for else if, it seems like. Okay, so else if defined forward base pass then end if. Okay, so in deferred pass we need to set the light direction I guess to float 3, or I guess we could just put 0 there. And also the color. And then in deferred pass, we just won't apply lighting to it. Oh yeah, we won't. I'll have to do a little bit more for deferred, but this is a start. Yeah, so else. There we go. So else will just return the color. This won't really work because we have to add everything to the different render targets. But let's go ahead and see. Oh, right. Float 4. We just add 1 to alpha. Okay, I'm surprised that nothing else is happening. Or does our camera, it uses graphics settings. So if I change this to deferred, and if we look in game, why? Okay, I don't know what's going on there. I was dragging with the right mouse button, and for some reason it's having all different colors. Okay, so obviously the deferred rendering doesn't work that well. Weird stuff is happening. But it's kind of there. I mean, the rest of the game works okay. Although Is this this Toon shader would not be deferred, I think, because it has unique lighting, so it's actually using the rendering or forward rendering. We can actually look at the frame debugger. So it's rendering deferred here. And if we see the game, we can see like what it's doing. Yeah, so it's rendering these, the color, and now it's doing the forward objects, so it has to do depth for the forward objects. Okay, that's for ambient occlusion. Okay, now this is the deferred lighting pass. And now it's doing shadows. Shadows are kind of cool because it basically renders a depth map from every light. But yeah, this is fun to look through. But yeah, it doesn't make a whole lot of sense right now. Okay, now it's doing bloom. Okay, let's... Yeah, I think their scene is too complicated now to actually get any information from it like that. So let's make a test scene. And I think I'll just cut... I don't know if Unity can do that. So I'll copy this and move it to the test shaders. And then in play, well, I want the camera to use deferred here as well, so, but I'll delete this. Okay. Let's go ahead and put the camera on an anchor just so that it's a little easier to deal with. And I want it to have a similar field of view to the rest of the game just so it will be, I guess, comparable. And clear flags, I will leave skybox. Lighting. Just want a flat color, I think, for the ambient. Okay, this will be fine. Maybe we should get rid of the skybox. Okay, so now in game, nothing is shown because these objects, their deferred pipeline doesn't work. So if we switch back to forwarding, or forward rendering, they do show up. Oh yeah, there's no anti-aliasing in forward rendering. Okay, but now if we go to the frame debugger, we can actually, I think we'll be able to tell more what's going on. In fact, let's turn off the shadows for this light. So now there's no shadows. So it's drawing the mesh for each of the objects. And then it does, or where's the depth texture? I know it needs a depth, but. Okay, and then here's where it's trying to do deferred lighting, but nothing is actually set. So that's what we'll do next. And to support deferred, you have to output more than just a color from your fragment function. Which we saw earlier when I was looking at Catlight Coding's code here. So we'll just copy this. I think I want to put all my structures up at the top. So this will be, I guess we just copy it. I should have copied the whole block. So yeah, if it's deferred pass, we have a bunch of graphics buffers. And this is for shadows, which we're not going to deal with right now. And what these do, by default, the color is in the RGB, and then something called the occlusion is in the alpha. And then this one has, I think, I guess I should call this Albedo. And then Specular is an RGB, and then the smoothness, which is used to give the size of the specular highlight. And then normal is an RGB, and alpha is unused. And then in this last one is used to accumulate lighting effects over the different lights. So this is just lighting. I think alpha is also unused, but you can insert something here if you have something called an emissive light, which is basically just a light that the object itself outputs. We might change this because, for instance, we don't really need this normal. Or wait, no, we do, because we have to use normal to get the dot for the light, so. Okay, so now instead of just returning a float 4, we need to return a frag out. And okay, so we should define this right here. So O dot G buffer 0. Oh wait, this is, yeah, this isn't deferred, so. It's just the albedo. Why change this to albedo just to make more sense. And then we won't have any specular right now, so G buffer 1 is, we'll just set it to 0. G buffer 2 is the float 4 dot normal. Or actually it should be a 0, just to use homogeneous coordinates. And then G buffer 3 is 0. Okay, and then here, dot color. Right. And I think one thing I want to make sure is if we just do pass through the normal, or if I need to transform the normal in any way. Okay, so we. Oh, this is so, I guess, so it's in from 0 to 1 instead of -1 to 1. Oh. We'll just copy it because, yeah, we have the normal the same way, although cat-like coding has a bunch more information that they use their normal for. But I'm pretty sure the normal's just passed right through. Alright, so now in deferred, something should show up in the game, and it does. Am I still set to deferred? Yeah, so yeah, now we actually have a character, or something shows up because we set all the values in the deferred output. And of course the difference again is deferred uses Unity's physically based rendering instead of our Toon shader. So we need to fix that. And in order to do that, I need to write my own lighting effect. So Unity has this graphics a window, and it looks pretty intimidating, but really we're not going to worry about most of the stuff except we need to change deferred to our own custom shader. And to do that, we'll just create a new unlit shader, and this will be Toon Deferred Lights. Why did I do that? Okay. Yes, convert. And I guess I'll just put this in there, even though it really should be hidden because we won't want to apply this to any material. Gosh, I can't think. So no problem so far. And just to make sure, if I look in here, yeah, it doesn't show up. And if I put it into the graphics settings right now, I think the game will probably complain. Yeah, so it needs at least 2 passes. But I think the second pass doesn't actually have to include anything. If you look at how... Yeah, right here. Deferred shading. Like the second pass... Yeah, I've just basically... Oh, I see. Okay, yeah, this is something a little confusing about deferred shading, which we might have to fix. Unity stores colors differently depending on if you're in high depth or HDR mode or not for the camera. And the second pass is to decode the colors to the real colors out of that, I guess, low depth of range colors. And it does it logarithmically, which is why I have this negative log 2. I guess we better do that. Yeah, no properties. I'll just copy this and we can use it as a base. Wrong file. Okay, so we'll need to add our own things in here, but... Oh yeah, so it uses stencil backgrounds and things for light. So I'll just leave this in here because I think Unity sets them. When you put a value in a bracket, it means that it's some property, and I guess Unity will set them. Yeah, because Catlight coding doesn't have them up here in properties, so I'll just leave it. And it uses a stencil buffer, which we also did a bit in the 2D lights section, to basically, when it renders lights, because, well, directional light lights the whole scene, but every other light only lights a part of it, so Unity uses a stencil buffer to decide what part of the image a light will apply to. I'll just leave that. I think we don't really need to change this at all because Unity has it all. It's only to decode the light. Probably, and now it's gonna say that it doesn't include that CG include file, or that CG include file doesn't exist. So I guess we need to create our own CG include file for this. We could write it all here, but I just find it's easier, and well, I guess not really easier, but it's cleaner to include most of the code in a CG include. So .cg include, oops. And again, we'll need to do this little hack at the beginning so that the shader or CG won't define or pull in these functions twice. So Toon deferred okay. And so if we look in the CG include file for this deferred lighting, which is my deferred shading, it gets all the graphics buffers which Unity provides. And the reason I'm going to copy a lot of this code and then work from there is because you have to use these exact names for the function or for the textures that we get from the graphics buffers. And remember, these graphic buffers 0 through 4. Why does it skip 3? I actually don't know that. Oh, actually, I think I do know, but the 0 through 4 correspond to what we pass to these G buffers 0, 1, and 2. So again, this has Albedo, Specular, Normal, and then this would be Shadows, but we don't need that one. And the reason it skipped 3 is because the 3 is actually what we write the values from this shader into. Okay, and then yeah, it has some extra stuff for different lights. We probably will need most of this, but so the vertex function is really simple. It just needs to transform the position and normal. But actually, it might depend on what kind of light, so we'll go ahead and copy all this code, but I'm going to cut out stuff for lights that we don't need right now. I mean, I guess we could to support them all so I don't have to add it back in. Because really, we're going to use this exact code except add in our Toon ramp. Okay, so yeah, this is basically for point lights with a cookie. Okay, we don't have shadows right now. We're not even supporting that. Yeah, it's gonna be easier for me if I just start simple, I think. So I'll get rid of this stuff. That's for light cookie. I think this is the matrix for world coordinates to the light coordinates, so we'll probably need that. Don't need a shadow texture. We'll need the light color and the direction, and well, not the position for directional, and that's for something else. No shadows. Okay, so this will be create a light, and yeah, I'll come back to this, I think. Okay, so the vertex function, again, I'm gonna change these so that they'll be the same as the standard. Although I kind of like the names that Catlight Coding uses better. Oh, I press Control F again. And then interpolators to V2F. I just want to use the default Unity ones just to make things easier. Okay, so again, we just transform the position using the object to clip position, and then the UV is, we get the screen position from whatever UV is passed to us. Or wait, we get the screen position from the actual world position here. And then the ray is basically, well, if you look at a camera, let's look at a camera. We can see it looks kind of like a trapezoid or a pyramid. It's not really a pyramid because it has a flat face at the front, but the ray we really need to point along this direction so we can get the depth of any pixel based on those rays. So let's use this. Object to view position, okay, and then it flips it. Probably, yeah, because I think Unity space starts in the bottom left. I might have this backwards, but then screen space, oh, Unity space starts in the bottom right, and then screen space top starts at the top left. So that's why we have to flip the X and the Y. Okay, and then we lerp it based on the normal. Oh, I see what's going on here. Yeah, so we don't actually need this lerp because if the light is a quad, which is what this means, which means it's a directional light, then we'd actually have to... Oh, wait, I'm not explaining this well. So if it's a directional light, I think Unity passes in the rays with as a normal. But if it's not a directional light, then we'd actually have to compute all the vertex positions. And for now, we're just using directional light. So again, I'm going to simplify it just for my sanity. Later on, we'll come back and add more lights one at a time. Okay, so the fragment program, we kind of will just copy most of the code that we wrote here. It'd be kind of nice if we could duplicate it somehow. Maybe another CG include file. So that we would be able to share logic in case I... Another problem is how do I get... Oh, I think there is a way. But I don't know. I need to figure out how to get the Toon ramp onto this shader. I think I can set like a global variable, so that's not that big of a deal. Okay, so let's see. I didn't name these files very well, did I? Okay, so let's name this to Toon material lighting, and then I'll make a separate Toon lighting, which will actually have the light algorithm. Okay, and let's change that, and then in our shader, we'll want to, oops, I didn't mean to delete that. So we'll want to include Toon material lighting. Okay, and then we'll have something in common to both of those shaders. CG include. Okay, so end if, and this should be Toon lighting. So this would be pretty much where we'd have our own copy of that Unity physically based lighting function. But really all it needs to do is just call a Toon ramp. Okay, so the lights would be created differently for each, so we can't have that in common. Okay, so this will just return a color. Toon, not ton lighting, Toon lighting, and we'll pass a float 3 albedo and a unity light, and we'll pass a lot more later, but that's good for now. We also need the normal, so float 3 normal. And then it's going to need to get the Toon ramp, so I think we can do sampler 2D Toon ramp. Okay, so and Toon material lighting would include Toon common lighting. And then down here, we just call that new function I just created instead of all this. We'll still need to create the light, but. So this is Toon lighting. Is that what I called it? Yeah. And we pass the albedo, the normal, and create light. Okay, so let's test that. No, it does not work. Let's change this to forward. And I think I'll go into the project settings and get rid of our custom shader for now. Okay, so obviously it's still not working because something happened here. Okay, trying to figure out how to get that arrow to pop back up again. That didn't do it. Maybe if I change something, it would recompile. Okay, Toon deferred lights, can't find include file. Okay, well we don't care about that. Oh, it's just a sampler ID. I think it has to be capitalized. And Toon deferred are, yeah, the shader here. We'll just want to include Toon deferred lights. Maybe it'll stop complaining about that. Okay, unrecognized identifier unity light. Oh, right. So we don't set the color, we just return it. And then Toon deferred lights. Oh, so this should be unity light, light. Oh, I don't have the right include files, so let's get that. I'll just get all three. I'm not well, this probably won't need the auto light. because I think that's mostly shadows, but yeah, I'm just trying to get it to compile. Okay, so light color equals 0, light position equals 0. Valid subscript. What is it? Material lighting. Oh, it's direction, not position. And then also in this, I just need to take out the Toon ramp because it doesn't need to be defined here anymore. Cannot convert float 3 to float 4. Oh, right. I need to float 4 and then again, just give it an alpha. Okay, so now it's working again in forward rendering. Okay, what's this? Semantics and type overridden by variable function on closing type at Toon material lighting 59. I don't know what that means. Oh, okay, I don't have to pass SV target. I think that was the issue. That used to be before we had a structure that we returned. All right. Okay, so now this works, and if I go to deferred lights, I can, yeah, I already have the Toon common lighting. I don't need, do I need the view position? I'm trying to, well, I just need to create the light. So let's see, what is the, I guess it's just light color and light direction. And, well, I guess I should make sure that's how Toon, or cat light coding does it. So if it's directional, the light direction is actually negative. Okay, and that's for cookies. We're not going to deal with cookies right now. Where is it? And the color is always just light color times attenuation. And we don't have any attenuation right now. Okay, so this will be fine for us. I'm going to rearrange it. I think the vertex function should go up here. Hey, Alfie Gamer, good to see you again. How are you doing today? Okay, so we pass this stuff, but I don't actually need it right now, so I think I'll get rid of it. Okay, so this, again, is that Unity PRDF PBS function, which is used for Unity's physically based rendering, which is kind of its default thing. And that's pretty much what we're trying to delete right now, or get rid of right now. Or not get rid of, but rewrite so it has Toon lighting. So I think we just need the normal, and we already, well, that's written in the camera buffer, so the albedo. Yeah, I'll get rid of that for now. We don't need smoothness. And the normal, so we have to, yeah, convert it back to -1 to 1 space. don't need that. And so for the Unity light, I don't need to do anything either. And we don't have indirect. So, okay, we just would call Toon lighting here. And we pass Albedo, the normal, and the light. I guess, yeah, we don't have to pass anything there right now. Doing good. Okay, I'm glad to hear it. Not too bad. I'm trying to write my own Toon shader here, and so far it's going pretty well, so I'm feeling good about that. I guess I don't really need the depth right now. But I guess I'll keep that up there. Oops. Yeah, we'll probably need all this later, but... Okay, and you might wonder, why do we divide the UV? It's just something called homogeneous coordinates, so it's kind of hard to explain. I would just recommend looking in the Wikipedia if you're curious, but basically the coordinates here have been scaled by this W value, and so you divide by W to get the actual UV. It just makes it a lot easier to work with matrices in general. Okay, so I'm pretty sure we've gotten everything taken care of. Okay, so since we don't need the depth texture, I'll just comment that out for now. Let's see if there's any compile errors. Okay, so cannot convert from float 3 to float 4 at line 50. Oh, okay, so we have the same issue. We just got to add an alpha value of 1. Okay, so now our deferred shading should work. So if I change the graphics, oh, not quality, graphics, go back in here and change the deferred to another custom shader. Let's see, Toon, deferred lights. So far so good, and if I change the camera to deferred mode, hopefully it will look exactly the same. Okay, it does in editor, but not in game. Interesting. Okay, so something's wrong with HDR, but seems more like it's not reading the light correctly. So everything is just flat. So let's see what's going on. So for direction, oh, did I thought I did negate it. So yeah, for directional light. Okay, so this won't run if it's a directional light. And then this won't run because we don't have shadows. Okay, we don't have any shadows, so I don't even need to deal with that. Yeah, so then it's just the light color. Oh, there's no, I need to set the global Toon ramp variable. Okay, so right now I think what's happening, I'm surprised it's not throwing an error because there's no value for the Toon ramp in the shader. And I guess it just uses a flat gray. So in order to do that, we actually have to create a script. I guess it should be in the UX. And I'll basically need to run at the very beginning of the game and then never again. I'll just call it shader setup. I'll just make it a mono behavior. Or I guess it could be a... Well, so it'll work better in this test scene. I'll make it a mono behavior. It doesn't even need to do that. Okay, so on awake, it just needs to find our shader. Shader, find... So I think I called it Toon Deferred Lights. And I think I can set a variable. I know there's some way. Okay, I need to look it up. Unity set global shader variable. Maybe I'd have to go through a material. Okay. Let's see. Oh, so it's static. Okay, that was the issue. Their use of shader needs them, but the material does not have them defined. So I hope you can set a global texture. Okay, good. I guess I should have a reference to the ramp texture, so I'll make it private and serialized field so it shows up in the editor, and it's texture 2D ramp. And okay, so I don't even have to find the shader, I just call shader set global texture. Okay, and so I guess this would be Toon ramp. Okay, I think, let's see what happens. In the material, it might not work because Toon ramp is already defined in the properties. So I'll see if it complains about that. Okay, so shader setup, and then I just gotta give it the Toon ramp. Okay, so now, okay, we still have it on forward rendering, so looks fine so far. And no errors or anything. So if I change this to deferred, oh, it still works. It's a little different. Oh, it's because forwarding has anti-aliasing on, so if I turn that off, they should look exactly the same. Yeah, that's one bad thing about deferred lighting is that you can't have anti-aliasing based on the geometry. You have to do it as a post-processing effect, which will be okay. But yeah, they look... I don't think I see any changes. Okay, so that's the beginning of our Toon shader. Let's see. What else do I want to add? Oh yeah, we need to do specular, rim lighting, outline, and I'll need to support more lights. Point lights, spotlights. I don't know if I'll use cookies. If you don't know what a cookie is, it's basically an image that you can put on a light and the light will be shaped like that. Well, I will need a cookie for directional lights because otherwise they'd be Just squares. Yeah, I think I will. What would this game be? It's going to kind of think like, I can show you a little bit, but if you try to combine the grid-based battle system of Fire Emblem with like the team building and kind of mind games that are present in competitive Pokemon battles, that's my goal. Excuse me. That's my goal. And right now, I mean, we pretty much got a lot of stuff done. I'm kind of going on a graphics pass right now. Let's see, the monsters can jump around, and later on you'll be able to set different monsters, and in the future I'd like to do some kind of story mode with actual monster capture and everything. But that will be in a while. We don't actually... They can't actually do any damage to each other, but they can jump around and look cute. Looks great. Oh, thanks, Offie Gamer. That's nice of you to say. Yeah, we actually just finished the animations today and moved on to the shader, so I'm excited about that. Alright, so... I guess I was doing to-do. So we want to do spotlights, and I guess we will have to do cookies. Well, that'll be nice. So spotlight. Well, yeah, at least need to do spotlight cookies. Because, like, I already have an idea for another monster, and I want it to have, like, shining eyes. And so we'll use spotlights for that. And if you don't have cookies enabled spotlights, it's kind of output in a rectangle shape. But I actually want it to be more round, so... Again, the spotlight, yeah, kind of like this. But again, if you don't have cookies enabled, it's actually going to be in a square. What else? Oh, shadows, that's important. And then I guess that'll be it for this. We'll need to update the terrain shader. But I think, oh, I haven't saved this yet. Let's go ahead and do that. So Unity, assets. This will just be Toon ramp. So we have PNG, so I'll just save this as SVG. But back to test shaders. So basically, like adding different support for lights is as easy as having a bunch of different if statements for different types of lights and getting all the data for them. I think some of the cookies are a little difficult to deal with, but most of the lights aren't really that hard. We just have to, like, here we would have if directional light, and then else if spotlight, so on. I guess, oh, we'll need to do specular. I wonder, I'm not sure how reflections would look with a Toon light, but we'll definitely want to have ambient lights. That's not spelled. I'll look into that. So I think that's going to be our roadmap. Hopefully the shader won't take too long. And then I'd like to do some more gameplay stuff, either implementing some terrain types or other types of actions. We'll see. But yeah, I think I better wrap it up. I'm getting pretty hungry, so I'm gonna get something to eat, and maybe, yeah, I guess the latest I'll be on tomorrow around noon Eastern time. And of course, if you'd like to be notified when I go live, you can follow me here. I also will post on Twitter. And if you missed any of my streams, I do have a YouTube channel where I upload everything, and finally have a Discord where you can chat with me throughout the day. I'd love to have you there. And yeah, tomorrow we'll come back, finish up the shader, or at least do more work on it. Let's add a check mark. We've got Albedo, directional lights, and deferred. Oh gosh, I can't type. I think I misspelled every one of those. But anyway, hope you all have a great day. Okay, I'll see you later, Alpha Gamer. And yeah, I'll see all you later too. Bye-bye.